back to the course on Foundation Engineering. In today's lecture, we'll try to understand what is meant by Cofferdam, what is the necessity of Cofferdam, what are the different types of Cofferdam structures that we come across with, and what type of Cofferdam structure is used in what conditions. So all these particular cases is what we'll try to come across in today's lecture. So coming to what is meant by Cofferdam. So Cofferdam is basically, it's nothing but it's a kind of a temporary structure what we are going to be constructing, or which is basically designed to keep water and or your soil out of that particular region in which you are required to take up the construction of any bridge pier or the caisson foundation. That's nothing but your deep foundation. So in the purpose of construction of your deep foundation across your water bodies or in the water stagnated areas. So in such particular case, as I mentioned in our earlier discussion, okay, we will be requiring what is called as a temporary structure what we are going to be constructing to divert the direction of the water flow or to arrest the movement of water flow through that particular region in which you are required to construct your deep foundation. So in all such particular case, you prefer to go for a temporary construction which is designed to keep the water, and it need not be only water, it can also be even water along with your part of the soil out of that particular region in which you are required to take up the construction of your bridge foundation. So this is how typically a cofferdam structure looks like. This is what we call it as a circular cofferdam. The cross section of that cofferdam structural arrangement is in circular shape. Okay, so you see that in the surroundings you have the water available, but this particular area first initially is what is roughly barricaded by outer cofferdam structure. Inside that region, once again you are trying to construct another cofferdam to take up the construction of your bridge pier here. So typically you wanted to have the construction of the bridge pier there. So for that you are trying to create a temporary structure there which is acting like a barrier for the water flow happening across that particular region. So this is another typical type of the cofferdam structure where you could see this is your river flowing region. So in that river flowing region, you are required to construct maybe a foundation or any other underground structure. So in such particular case, we are going to construct your cofferdam, which is arresting the movement of the water flow across that particular cross-sectional region. So through this particular region, the water flow is not allowed to happen. So in that particular area now, which is relatively dry in nature, so you can take up the construction of any required structure there. It could be your foundation or it could be any other substructure below that water body. You can take up the construction of it. Now, what are the certain requirements that your cofferdam has to satisfy in order to ensure that yes, this temporary structure can meet my requirements in subsequently taking up the construction of any foundation or any kind of structure in that particular area, what is barricaded or what is created by construction of your cofferdam. Okay, so cofferdam should be reasonably watertight. So whatever the cofferdam structure that we are going to be constructing in water flowing areas, okay, so across that water flowing channels or in that water stagnated regions, so where you are trying to take up the construction of this temporary structure which is called as a cofferdam, this should be reasonably watertight. It means that it should not be allowing the water to flow through the cross section of that cofferdam structure. Water should not be allowed to flow through that cross section of the cofferdam structure. It has to be reasonably watertight. But absolute water tightness is not desired in the case of cofferdam. In some cases, there will be some chances of water seeping through the cross section of your cofferdam through the joints, or maybe below the cofferdam cross section, or maybe through some cracks which got developed, or maybe some particular places where you had some failure or maybe some openings available. So through that there will be some possibility of water seepage happening in very small quantity. In such particular case, you can try to arrest the movement of water flowing through that even small cracks or small void spaces by making use of your cement slurry or any mortar or any puddle material. Puddle is nothing but a mixture of your clay and sand by making use of that slurry paste, you can try to close those void spaces or minimize the void spaces through which the seepage is happening. But however, 100% seepage cannot be completely arrested with the help of your cofferdam. But depending on your requirement also, sometimes you might be required to have a cofferdam structure which is completely watertight. So in such particular case, we have to think of how to see for all those seepages what are happening into that cofferdam structure, how to minimize all those effects is what you can think of. But however, absolute water tightness is not desired in the case of a cofferdam, in case of all different type of structures where you are taking up this cofferdam temporary structure construction. This is designed in maximum water level flowing conditions only. Okay, so whenever you are looking at the construction of this copper dam, we'll try to first understand what is the maximum water level flow or maximum flood level existing at that particular river flowing region. So based on that maximum water level consideration only, you go on to design your temporary construction there. And groundwater or water lying above the ground level should be excluded. When you are trying to think of the construction of your coffer dam, you will not be basically taking into consideration of the stagnated water or the water level which is already existing. So you have to take into consideration of the fluctuation of your water table condition and fluctuation in your tidal conditions, fluctuations in your water flow, the depth of the water flow. Also, all those particular aspects are going to be playing a major role in deciding what shall be the height to which your coffer dam construction has to be, and subsequently what type of coffer dam construction has to be. You will be making use of your different types of materials, like it could be a timber material, it could be earthen material, it could be steel material, it could be RCC material, or plain cement concrete material, whatever could be the type of material which is available and suitable for that particular construction, depending on the velocity with which the water is flowing there and depending on the depth of water flow what is existing there. So you'll be typically using the different types of materials in the construction of your coffer dam structure. And it also even depends on your availability of those materials. It's not that I'll be just thinking, okay, this material is only I'll be using. And we should also even think of the cost effectiveness in terms of the availability of materials in the nearby regions for taking up that particular construction. And in the case of this coffer dam structure, all that construction whatever relates to that of your coffer dam is generally taken up at your construction site itself. So this coffer dam is constructed at site of work only. And the factors that govern what type of coffer dam that we need to construct basically depends on the depth of the water flow. It depends on the soil condition what is existing there, and it also depends on your difference in water level, how the variation in water levels are existing, and it also depends on your availability of your material. So here the depth also refers to that of to what depth I should extend my coffer dam. I have to drive or push my coffer dam structure relatively deeper into the ground to arrest your water seepage happening from the bottom of that particular structure. So all these factors would certainly dictate you on what type of coffer dam structure you have to prefer depending on the suitability requirement in your construction site. Now, what are the uses in which, what are the basic uses of this particular coffer dam construction? So, whenever you want to take up any construction of the deep foundation in the water stagnated regions, or in the case of your coastal areas, or in the marine regions, okay, and also in the case of your pile driving operations where you have your water seepage effect conditions existing, or maybe where you have the effect of lateral earth pressure issues coming into picture, where the failure of soil would happen in the construction of those pile driving operations. And in the case of construction of any new structures where you wanted some particular area which has to be kept dried without having any water flowing through that particular area. Okay, so in all such particular regions, without having any obstructions or without having any disturbance to your construction, so in all such particular case, we go on to provide this coffer dam temporary construction. Now, what are the factors based on which the choice of the certain type of coffer dam would be depending on? As we have said, like What type of cofferdam I have to choose? We have got different types of cofferdams one can think of to use in the construction. So it totally depends on various factors. So on what various factors you are going to be making a choice on what type of cofferdam you are going to be making use of in the construction there. So it all depends on how much area has to be protected with the help of the construction of that particular cofferdam, and what is the depth of the water that has to be dealt there by constructing your cofferdam, and what is the possibility of overtopping. Overtopping in the sense, when you construct your cofferdam, do you have any possibility of overturning effect in that particular constructed cofferdam structure? So taking into consideration of the possibility of overtopping. Why does this possibility of overtopping or overturning effects comes into picture? Because the water force which acts on the surface of your cofferdam walls would certainly result in what is called as the rotation in the cofferdam structure there, cofferdam wall structure there. Okay, so we have to understand, do we come across with any effect of overturning in such particular cofferdam if I am trying to provide? It all depends on the velocity with which the water is trying to flow there, the depth of the water flow, what is existing there. So various factors would subsequently dictate you, like whether you are going to encounter any such kind of overturning effect in that particular construction of the cofferdam. And it also depends on the availability of the materials at the site of your work, and it would also certainly depends on the materials which are to be used in the construction of the cofferdam, whether they can be easily transported to your exact location where you are required to take up the construction of that particular cofferdam. And how do we classify these cofferdams? Okay, so cofferdams can be classified into many types depending on the depth criteria, depending on the soil conditions, depending on the fluctuations of water table or water levels in that particular area in which you are taking up the construction of the cofferdam, and it also depends on the type of materials which you are going to be using. So in such cases, if you are using a timber material, I may not be able to go for large heights to which the cofferdam construction can be taken up. If I am going for an RCC material, I can go for relatively larger heights. If I am using steel material, I can go for relatively larger heights to which your cofferdam construction can be taken up. So it depends on what type of material you are also using in the construction of that particular cofferdam. So typically your cofferdams are classified based on the depth, based on the material, based on your other aspects of water fluctuation. Okay, so depending on the soil condition, so types of cofferdams are classified as dikes. Dikes are nothing but kind of embankment structures. Okay, where those embankment structures can be of material earth, or can be of the material your aggregates, that's nothing but your rock or large boulder pieces. Okay, so with that also I can go ahead in constructing your embankment. That is what we will be calling it as dikes. And other types are single wall cofferdam or double wall cofferdams, cellular cofferdams, rock-filled crypt cofferdams, and concrete cofferdams. So these are some of those cofferdams what we are going to be touching upon in our today's lecture. So what is meant by dikes? Dikes is nothing but it's an embankment kind of construction what we are going to be talking about, depending on type of material what is used in the construction of that particular embankment. Okay, so that embankment can be constructed by means of an earthen material, or it can be constructed by means of rock pieces or large boulder pieces, or with the help of your sandbags, which are placed one over the other in the form of a staking. Okay, in the form of stacks, you will be placing your sandbags, and you will be subsequently saying, okay, this acts like a barrier, and that barrier is what I am going to be calling it as your embankment there. So earth dikes, when it comes to, so in which particular type we go for earth dikes, what is the depth of water which can be taken care of by constructing your earth dikes and so on. So let us try to understand. So this earth dikes type of cofferdam is suitable when you are required to handle the water which is relatively of shallow depths in the sense the depth of water which is flowing through that particular region is relatively 1 0.2 to 1.5 meters. So in such particular case only you deal with this kind of earth dikes. And these earth dike type of cofferdams are constructed when the velocity with which the water is trying to flow through that particular channel where this cofferdam construction is done, where the velocity is relatively low. Whenever the flow velocity is relatively low, in such case only you go for the construction of this earth dike type of cofferdams. And we should minimally provide what is called as a freeboard of 1 meter at least. What is meant by freeboard? Let's say if I am trying to look at my earth dike, earthen embankment. So the water flow, what generally would be existing is somewhere in between 1.2 to 1.5 meters, and this is what we call it as freeboard. Okay, so with respect to the maximum flood level, the top of your embankment should have at least 1 meter height. That is what we call it as your freeboard. And you should have a proper suitable side slope for that particular earthen dike structure, so that you will not have the failure happening in the slopes of that particular embankment what is constructed there. And top width of the bank has to be properly chosen to ensure a proper sloping can be provided with respect to the bottom of that particular embankment to minimize the effect of your failures of the slopes what are provided there. The material what you are going to be making use of in the construction of this earthen embankment or earthen dikes could be a mixture. It basically contains what is called as your fine grained soil, but it do not only go by what is called as your clay type of soil. You will also be having a mixture of what is sandy soil. So a mixture of clay and sand is what you are going to be using in the construction of your earthen dikes. And wherever you feel large void spaces are existing or interconnected void paths are existing, which is allowing the water to flow through the cross section of that earth dikes, you can arrest the movement of that particular water seeping through that by applying what is called as a puddle material. Puddle is nothing but it's a mixture of your clay and sand. So such material is what we call it as a puddle material. So this puddle material is a mixture of clay and sand mixed with water. Okay, more proportion of clay particles rather. Okay, so mixed with water. Wherever you find some openings available, which is going to cause seepage across the cross section of that earthen dike, you are going to be arresting the movement of water flowing through that by applying what is called as the puddle material over the surface. And you'll also be using what is called as a riprap material. So riprap is nothing but your aggregate particles, large aggregate particles, which are going to be placed on the surface of this sloping surface of the embankment. So to prevent the failure of your embankment slopes, and also to ensure that your wave forces because of the water movement do not cause the failure of your slopes of that particular embankment. So typically in the construction of that riprap, whatever these large aggregate particles that you are going to be seeing on the slope, okay, so these stone particles, what you are going to be using are relatively large boulder particles. What you are going to be using would weigh somewhere in between 70 to 700 newtons, so that those weights should not be very less and the weight should not be very high also. If the weights are relatively high, you will have the possibility that those stone particles would certainly cause, because of the excess weight, the stone particles might cause the sliding failure in that particular slope of the embankment. If the weight of the aggregate particles, if it is small, then your wave forces, sudden wave forces cannot be taken care by your large aggregate particles, which are relatively of smaller sizes. So after all the construction work of foundation, this particular Cofferdam construction, what we are trying to take up is helping in the construction of the foundation, which is required to be taken up on the other side, on the dry side of your Cofferdam, which is trying to entrap some area where you can take up the construction of that particular deep foundation, or maybe a pier foundation, or any other structural construction below the water body. And this kind of earth dike construction is not preferred in the places where you have the effect of overtopping situation. So when the water which is trying to flow through the cross section when the water which is getting stagnated there because of the construction of that earthen dike, if the resultant force acting on the walls of your earthen dike coffer dam, there could be certain situations where you would see the rotation happening in that particular structure. So in all such particular cases, you avoid the construction of your earth dike there. So rock dikes is as similar to that of your earthen dike, how it looks like. But in the case of your earthen dikes, the width of that particular embankment would be relatively large to provide a proper slope to ensure there will not be any failure happening in the slopes of the embankment there. But here you need not provide a so large width cross section of the embankment. So you can provide relatively lesser width of cross section of the embankment, because the rock dike relatively has larger strength to take care of the forces coming from your water movement and other aspects. So you can try to provide these rock dikes to a depth of what is called as 3 meters in height. So your Cofferdam rock dike type of Cofferdam construction can be constructed up to a height of what is called as 3 meters above your ground surface. And it also depends on the availability of rock there. And this is relatively said to be not impervious. Okay, so it's not impervious in the sense it is pervious, because in between one rock particle to other rock particle, you'll have large void spaces available. So in such particular case, if you have got large void spaces available in between one boulder particle to the other boulder particle, so those large void spaces, you have to pack them by making use of any puddle material or any other material, okay, by which you can try to minimize your seepage losses, or I don't say seepage losses, rather the flow happening across the cross section of that rock dike. So impervious layers of earth are laid on either sides of your rock dike, so that your flow happening through the cross section can be minimized. Voids wherever available in between your large boulder particles in the construction of the rock dikes are going to be filled by your earthen material, or it can be filled with what is called as your puddle material. Sometimes the core wall or core wall construction in the case of this rock dike can be taken up even by providing what is called as your steel sheet piles, so that these steel sheet piles will offer you, will minimize you the effect of seepage happening across the cross section of this rock dike structure. And the core wall, what we are talking about in the construction here, in the case of your rock dike, will be constructed by either clay or concrete. The central core part of the embankment, which is being constructed by your rock dike, so that central portion of it, the core portion of the wall, will be mostly constructed by your clay or your concrete to minimize your seepage what is happening across the cross section of that particular coffer dam. And this can be helpful in preventing your overtopping, and this particular type of coffer dam is relatively better than that of your earthen dikes. So this is how typically your rock dikes look like. And by making use of your sandbags, you are going to be constructing your Cofferdam structure. So what are we going to use here is, you are going to be using empty cement bags or any bags which are available, which is going to be filled with a mixture of sand and clay, and those bags are going to be placed in stacks one over the other, and that would certainly act like a barrier against the water flowing through that particular region. But however, as the sand and clay mixture would certainly also sometimes allow the water flowing happening through the interconnected void paths. So in such particular case, those interconnected void paths are those joints through which your seepage is happening can be arrested by making use of your puddle material. However, this kind of sandbag dike constructions can be used only relatively over a smaller depths, not for larger depths. Next is single wall coffer dam. So what does this single wall coffer dam mean? So typically these kind of coffer dams are suitable in the areas which are relatively smaller, where the area that is to be protected from water flow condition and so, where the area that is to be protected is relatively small. So in such particular cases, we go for what is called as your single wall cofferdam. Now, if you look at here, you have got some sheet which is driven into the ground, and those sheets which are placed one adjacent to the other adjacent to the other, which is going to form you a wall. Those sheets are jointed together by means of welding or by means of any riveted connections with the help of proper bracings. Okay, so those bracings are going to act like the supports to ensure that those sheets which are driven into the ground are going to be firm, and they give the stability against the rotation and against the failure what is expected to happen because of the water force which is getting exerted on the surface of that particular cofferdam structure. Okay, these kind of single wall cofferdams are preferred whenever the depth of the water flow existing there is greater than 6 meters. But however, the area in which that cofferdam construction can be taken up is relatively a smaller area. And in this typical type of single wall cofferdam construction, so you are going to be having something what is called as guide piles. You are going to be having what is called as wales and struts, which are either made of wood material or which can be either made of your steel material. So they are going to be using in giving the stability to those sheet piles which are going to be driven into your ground to ensure that your sheet piles which are driven into the ground are not undergoing any sort of failure because of your overturning or because of your sliding happening due to the water flowing through that particular region. So most commonly the sheet piles what you are going to be using there will be of wooden material or of steel material. So in case if you are going by wooden piles, those sheet piles, if they are by wooden material, the depth maximum to which you can go up in the construction of that single wall cofferdam is only up to 10 meters. But in case if you are using your steel piles there, then the depth to which your cofferdam construction can be taken up is up to what is called as 25 meters, because steel relatively has more strength against your failure due to the forces what are acting on it. So whenever it comes to the construction process, so you are going to be first what we do is let's look at this image, this picture, which clearly tells us okay how this process of construction is taken up. So first what we try to do is we try to drive your guide piles into that soil strata in which you are required to take up the construction of your where you are required to take up the construction of your cofferdam. So first we try to drive your guide piles into the ground, and after driving your guide piles into the ground, then you are going to be relatively driving your sheet piles into the ground, and these sheet piles are structurally connected to those supporting guide piles by means of what is called as your wales. Wales are nothing but the lateral members which are going to be connecting one sheet and the other adjacent sheet together, so that those individual sheets do not behave independently, rather they are going to be joined together to have a firm connectivity between them, and they are going to be acting like they will not be acting independently, rather they will be acting together to ensure that there will not be any kind of failure happening in them. So wales are nothing but the lateral members which are running. You can see here in the plan view. Okay, so this whatever you see here in the shaded region is what we call it as wales, where these wales are running in the lateral direction along the length of your sheet piles, connecting those sheet piles. Okay, so look at this picture. Yeah, so in this picture, if you look at here, this member is nothing but I'll be calling it as your wales, which are laterally running along the length of your sheet pile to give the structural stability to that particular sheet piles. And you have also got some other members which we are calling it as your strut members. And what is the purpose of this strut members is nothing but it is to give a proper bracing to your sheet piles which are existing in that particular construction. Okay, so first we will be driving your guide piles to a minimum depth of 3 meters below the ground surface in that particular region where you are required to take up the construction of your cofferdam. and then sheet piles are driven with the help of your guide piles or the guiding frame which is available there, and then you try to provide what is called as struts and wails to give the strength or the stability to that of your sheet piles what you are trying to drive there in the construction of that particular cofferdam structure. And then once your structural aspect wise the construction is completed, then you are going to be pumping out the water whichever got entrapped inside your cofferdam constructed region. So water is going to be pumped out of that particular area. Next is double wall cofferdam. So the double wall cofferdam is as similar to that of your single wall cofferdam, except that in the case of double wall cofferdam, you have a double protection in the construction of your. You have two independent walls which are once again structurally connected. So you are going to have, let's say, two sheet piles which are driven one adjacent to the other, where those two individual sheet piles are structurally connected by means of bracing once again, and those two sheet piles will certainly give you more resistance against your overturning effect because of your tidal forces or because of any other external loads that are acting on that particular surface of your cofferdam structure. Okay, so these kind of cofferdams are relatively used in very large areas, and when the water or the depth of the water which is to be stagnated there or stored there is relatively very high. The double wall cofferdams comprises of two parallel rows of sheet piles which are driven into the ground and which are structurally connected by means of what is called as your tie rods or bracings, one at each different levels. The space between the walls is generally filled. Whatever the space between one sheet pile to that of your other sheet pile, which are running parallel to each other, which are connected by what is meant by what is called as tie rods. So the space what is available between them to give more stability to those sheet piles, you are going to be filling it with what is called as your granular material, which can be either a sandy soil or gravelly soil or broken rock pieces, can be dumped into that hollow space which is available between those two parallel running sheet piles which are structurally connected by your tie rod. So in that hollow region, you are going to be placing it with your granular material, so that your granular material what is placed in between those two sheet piles which are running parallel to each other. So that space, once it is filled with your granular material gives more confinement to your sheet piles what are driven there, and it adds more stability to your cofferdam construction. So construction wise, it looks as similar to that of your single wall cofferdam, except that you have got double layer of your sheet piles which are constructed there, which are running parallel to one another. Yeah, this is the typical case of your double wall sheet pile cofferdam. So I can show you, this is one sheet pile which is continuously running in the length direction, and there is other parallel set of sheet piles which are running in this direction, and these two set of sheet piles whatever are running parallel to each other are connected by means of what is called as your tie rods. This is one tie rod, this is another tie rod, this is another tie rod. At different depths you will have your tie rods connected to give the lateral stability to that particular sheet piles which are placed one parallel to the other, running to some required length as per your construction of the cofferdam there. And this empty space what we are referring to, okay, this empty space would be certainly filled with your gravel material to ensure that your double wall sheet pile cofferdam will have more stability against your water force which is acting on the surface of your cofferdam. And the other types of cofferdam is what we call it as cellular cofferdam. Okay, and this type of cellular cofferdam is relatively more suitable in very large areas where you are required to take up the construction of any underground structures below the water stagnated areas or water flowing areas, or very large foundations which are required to be constructed, maybe for some bridge piers or maybe for some storage tanks which are to be constructed below the water bodies. So in such particular areas, you can prefer to go for this cellular cofferdams. So these are preferred when water layer or the depth of the water flow what is existing there is more than 20 meters. So in such particular case, we prefer to go for what is called as your cellular cofferdam. So most common types of cofferdams, okay, are uneconomical to use basically. So the common types of cofferdams what we are trying to talk about always may not be suitable as per what your planning is. So it also depends on various aspects, as we have said. It also depends on the material availability, because we cannot simply say I'll be simply going by this kind of cofferdam construction. So it depends on economical aspect wise. You have to take a best decision in deciding on what type of cofferdam you are going to be using there. So this typical type of cofferdam, that is your cellular cofferdam, is mostly used in the construction of your dams or in the weir structures. Okay, so in such particular cases, you'll be preferring to go for this cellular cofferdam construction, where the depth of the water which is to be stored on the either side of your cofferdam structure, on the outer side of your cofferdam construction, so where the depth of the water to be stored is relatively high. Cellular cofferdam is made by driving straight web steel sheet piles. Web steel sheet piles, in the sense they are going to be having some cross sections like this. So this kind of cross sectional sheet piles is what we call it as web steel sheet piles. So that whenever you have such kind of cross sections, when one sheet is placed over the surface of the other sheet, you can have a proper interlacking what you can have between one sheet to that of your other sheet with a proper jointing mechanism, arranged to form a series of your interconnected cells. Finally, the cells, whatever are getting formed there in the construction of the cofferdam, are filled with either clay or sand or gravel to make them stable. First, the cellular cofferdam, what you are going to be constructing, first it has to be stable. Then in that stable condition of that cofferdam structure, then you can take up the construction of any kind of foundation or whatever in that region what you have created by constructing that temporary structure. And when it comes to the case of this cellular cofferdam, you are going to be talking about two different types of cells which are going to be used to connect one portion of the cofferdam to the other portion of the cofferdam. So those cells with which you are going to be constructing this cellular cofferdam could be either by means of what is called as diaphragm cells or circular cross-sectional cells. Cell is nothing but this shape what we are talking about. Okay, so these are nothing but we will be calling them as your cells. Okay, these cells, what they are going to be doing, they are going to be structurally connecting one circular cross-sectional cofferdam to the other circular cross-sectional cofferdam. So those individual circular cross-sectional cofferdams are cellular cofferdams are connected by means of the cells. These cells are what we call it as your either diaphragm cells or your circular cells. So when do I say that the cellular cofferdam is constructed by means of what is called as your diaphragm cells? Diaphragm cells are nothing but your the cross section. If you are looking at the walls, what you are typically looking at are not curved in shape, rather they are going to be relatively horizontal in shape. So such kind of cells is what we call it as your diaphragm cells. And based on the usage of those diaphragm cells, we are going to be constructing a cellular cofferdam. So the radius of the arc of that particular diaphragm cell are equal to the distance between those cross walls. So this is one cross wall, this is another cross wall. So the distance between them, let's say if it is x, so the radius of this particular diaphragm cell what we are going to be using there, so the radius of this diaphragm cell is typically equal to that of your distance what you have between those cross walls which are existing there. And the filling, whatever the empty region what is getting formed in between those cells which are constructed are going to be filled with your sand or gravel or whatever material which is available there. So it can be by your rock pieces also. They are going to be filled in this particular region to give the stability to that particular cellular cofferdam construction what you have done there. So if it is a cellular cofferdam with circular cells, the cross section of the cofferdam typically looks like this in the plan view. Okay, so where the radius of this particular arc is typically around 2.5 meters. So 2.5 meters, in the sense you can imagine what is that area in which that particular construction of the cofferdam is being done. Now, the advantages of this particular cofferdam construction, that's your cellular cofferdam construction, is the construction can be taken up relatively at a very faster rate by joining one cell to the other cell. And these particular cells, what you are going to be constructing in the case of your cellular cofferdams, they are said to be self-supporting. You don't require any structural stability constructions additionally to be taken up. Okay, so why do we say they are self-supporting? Because you are filling the empty space what is there in between that cells by your aggregate materials, which can give you the relative stability to that particular cells what you are going to be constructing there. Less quantity of steel is required per running length. Why do we say less quantity of steel is required? Because you are not using large cross-sectional areas of steel material. What you are going to be using there is your sheet piles, web-shaped cross-sectional sheet piles. So in such particular case, the thickness of the sheet pile is relatively less. So that's how you can minimize the cost in the construction also. And the other type of cofferdam what we will be coming across is what is called as your rock-filled crib cofferdam. Okay, so already if you can recall, we have talked about what is meant by crib wall in the construction of your retaining structures. Okay, we said crib wall is one type of your retaining structure. So here what we are talking about is your rock-filled crib cofferdam is nothing but is as similar to that of the case what we have talked earlier of your crib retaining structure. So that crib retaining structure is otherwise we are calling it as your rock-filled crib cofferdam. So crib is basically nothing but it's a box which is going to be filled with large stone pieces or aggregate particles which are going to be filled into that. Or it could be by the other earthen material also, which can be filled into that particular box. And the arrangement of that particular box, first what we create there is a kind of a box or a mesh which we are going to be creating, and inside that mesh you are going to be placing your rock or gravel or your earthen material to avoid to ensure that overturning or sliding effect do not happen in that particular cofferdam what you have constructed there because of your water force what is acting on the surface of your cofferdam. Typically this kind of rock filled crib cofferdam can be constructed up to the depths of 10 to 20 meters above the surface of your ground. And these construction of rock filled crib cofferdam can be limited to only smaller spaces. Only these kind of cofferdams construction can be done relatively in smaller spaces only. And the construction of this particular rock-filled crib cofferdam is relatively cheap because the material most commonly used in the construction of the box-shaped structure, that is your crib what you are going to be talking about, is done by your timber material, which is very commonly available everywhere. And these kind of rock-filled crib cofferdam constructions are going to be more effective and useful in the case when the water flowing through that particular area where this cofferdam construction is required, where the velocity with which the water is flowing through that particular region is relatively high. Okay, so the rate at which the water is flowing through that particular region is relatively high, or the flow with where you have a rapid flow happening through that particular region where you are required to take up the construction of the cofferdam. So in such particular case, your rock-filled crib cofferdam is going to be more effective. So this is how typical your rock-filled crib cofferdam structure looks like. It's as same as that of your crib wall, which we have called it as one type of your retaining structure, whatever we have discussed earlier. So construction wise, it's as same as that of the other copper dam structures. Okay, so what we are going to be doing here is we try to make a box kind of an arrangement. Into that box, we are going to be filling it with your aggregate particles. Next is the concrete coffer dam. So what is meant by concrete coffer dam? Your coffer dam wall which you are going to be constructing is by means of your RCC material, or it could be by means of your plain cement concrete material. If the height to which if your construction is limited, then you can simply go for your plain cement concrete wall construction. But if your the forces acting on that coffer dam wall, what is to be constructed, if it is relatively high due to the water which is flowing through that region, or the depth of water which is to be stagnated there, if it is relatively a larger depth, so resultant force coming due to the water stagnated if it is very high. So in such case, you will be required to go for what is called as your RCC panel walls to ensure your to give larger stability to that particular coffer dam construction. So here also typically you will be making use of what is called as your sheet piles, which are going to be driven into the ground, and to some extent it is relatively driven into the ground, and some portion it is going to be above the ground surface. But mostly those panels what you are going to be making use of in the construction of the coffer dam are precast RCC piles, are precast RCC sheets which you are going to be using as the panels in the construction of the coffer dam above your ground surface. And this type of coffer dam is relatively a costly one, because you are going to be constructing those coffer dam by making use of your precast RCC material. So all the other coffer dams what we are talking about, the material, once your required construction is completed in that particular region, required construction of your deep foundation or any other structure below the water body, the required construction is completed, then your temporary structure, the so-called coffer dam, can be dismantled, can be taken to some other new place where it is required to be once again constructed. So coffer dam, as we are saying, it is a temporary structure. Temporary barrier is what we are trying to construct there. So once we say temporary, you are going to be dismantling that coffer dam what you have constructed there once the purpose of the coffer dam is completed. Okay, so but when it comes to the case of your concrete coffer dam, as the construction of the walls of the coffer dam is mostly by your precast RCC pile material and RCC sheets what you are going to be using, so those materials cannot be reused in most of the cases because of various damages that you will be encountering. Okay, so these are going to be relatively more effective in avoiding the vibrations in that particular structure in the process of constructing any deep foundation inside that particular region of your coffer dam construction. So any kind of coffer dam that we are going to be talking about, the main challenges what we are going to be coming across with is in preventing the leakage. In preventing the leakage, what is expected to happen through the cross section of your coffer dam structure there. So how are we going to prevent the leakages in the case of your coffer dam structure? So leakage through your sheet piles, or below the sheet piles, or through the cross section of the sheet piles, through whatever voids which are available, through the openings which are available because of your cracks that got developed. Okay, so whatever it is, they are going to be those leakages are going to be minimized by what is called as your grouting technique. So you can try to grout those void spaces by pumping cement slurry, or by pumping your concrete slurry into that particular voids or large cracks which are available, so that your seepage losses or your leakage losses happening through the cross section of the coffer dam can be minimized. You can make use of your clay or sand or any other fly ash material which can be dumped around the region of your coffer dam where you are required to take up its construction. So that first, once you dump your clay or sand or fly ash material in that area where you are required to take up the construction of the coffer dam, so first you are trying to elevate the ground position and into which you are taking up the construction of the coffer dam, which would ease your process of the construction there. So typically we'll be making use of what is called as V-shaped wooden panel materials, which would give you more stability to that of your single wall cofferdams, which can help in minimizing the effect of your leakages. Wherever you find there is a leakage, if that is a small leakage or a small interconnected void path which is available, you can fill that void spaces with the help of your puddle material. Or if the leakage is relatively large with more force of water is trying to flow through that, they can you can think of going for your grout material, where the grout material what you can use can be by making use of the cement or by making use of your concrete slurry. So depending on the requirement, you can make use of what is essential in the process of prevention of the leakage happening through that particular cross section of the copper dam. So this is something what you can typically see here, where one sheet pile to the other sheet pile, whenever you are trying to join to each other. So you might have some kind of a joint which is not properly overlapped one over the other, where proper welding is not done, a proper jointing is not done one with the other in such particular case. So those joints can be properly done by a welding mechanism or by injecting some grout into that joint space what is available, so that your seepage, whatever is expected to happen through its cross section, can be minimized, or you can try to address the complete problem by making use of the required grout material there. So the interlocks between your sheet piles, sometimes through those interlocking regions where proper welding is not done, or maybe through, though a proper nut and bolt connection or riveted connection is provided, but through that joint connection also there could be some chances of leakage happening. So in such case, you can apply proper grease over the surface of that riveted joint or maybe nut and bolt joint, so that through the grease you can minimize, by applying the grease, you can minimize the effect of your leakage there. So in the case of your double wall coffer dam, as you have as you are trying to drive piles through the filling material on either side of your sheet, you are trying to minimize the effect of those seepages or leakages which are expected to happen in the case of your double wall coffer dam. And you can also use some type of material which is filled in between those two sheet piles which are running parallel to each other. So the material what can be filled inside can be a kind of a material which undergoes swelling, which tries to have increase in volume taking place because of any moisture which comes in contact. So once the volume increases, automatically the interconnected void paths which are available within that particular volume would get decreased, and resulting in the prevention of your leakage happening through that cross section there. Now, what are the different advantages that we have got in the construction of your copper dam? Okay, wherever your environment for construction of any particular structure is a poor condition that you have got, whenever you have a poor environment in the construction site, okay, poor environment in the sense, let's say if it is a river flowing region where I am required to take up the construction of a bridge. So in such particular case, environment is not very supportive for us to take up the construction of the structure, direct construction of the structure there. So in such case, I require what is called as a coffer dam to obstruct the flow of water. Then you create an area which is now suitable for your construction to be taken up. So in all such particular places of poor environment, you require your coffer dam to create what is called as a safe environment. By constructing this coffer dam, what we are trying to do, you are trying to create a safe environment for subsequent construction of your deep foundation or any other structure below the water bodies or across the water bodies can be taken up. So you have a proper design responsibility in subsequently ensuring, because if such kind of coffer dam construction is not done, without which if you are trying to take up the construction of a deep foundation directly, so you will face many challenges in the construction. It's not possible to install or drive a pile or construct a deep foundation directly when you have water flowing or when you have some difficulties or challenges existing there. Okay. So you can have more comfort in the design of any of your deep foundations or any of your substructures below that particular ground condition, where the environment is not very much suitable. Okay, so you can make that environment more suitable for your construction by taking up the cofferdam structure construction there. And one important and major advantage that we have got with this particular cofferdam is reusability of the materials. So the materials what you are going to be using in the construction of your cofferdams, it could be your sheet piles, which could be your guiding members, which could be bracings, or any other material what you are going to be using. Most of that material can be reused in the construction of the cofferdams elsewhere according to your requirement again. Okay, so the material whatever we are going to be using, the construction of the cofferdam itself, which is said to be a temporary construction. Okay, so once the requirement of the cofferdam is completed, then you will be removing all those components which you have used in the construction of the cofferdam. Those components are going to be removed and they are going to be reused at some other place where you will be requiring once again a construction of the cofferdam. Okay, so as I was talking about the puddle material which we are going to be using to ensure that the leakages whichever are expected to happen can be minimized. So that puddle material what we are going to be making use of is nothing but it's a combination of the clay and sand or clay and gravel. So depending on the size of the void, so you are going to be typically using the type of combination of the clay with the sand or clay with the gravel to minimize those leakages that are expected to happen through the cross section of your cofferdam. And sometimes depending on the condition what you are looking at, you are going to be purely using only the clay material, which is going to be typically acting like an impermeable material. Only the clay, it's not just combination with the sand or gravel. Only clay will also be sometimes used to arrest those leakages whatever are expected to be getting developed there. Now, what are the various factors that are going to be affecting the design of your cofferdam? In this particular course, we are not going in through the details of the design of a cofferdam, okay, and the steps involved in the design of the cofferdam, that we are not mainly focusing on. Okay, we are just trying to have an outline to what is meant by a cofferdam, what are the different types of cofferdam, and what are the advantages that we have got, what are the factors that are going to be affecting the design of that particular cofferdam is what we are in an outline we are going to be learning about it. So what are the various factors that would affect the design of your cofferdam? Design in the sense, what is the height to which I should construct that cofferdam? What is the area in which that particular cofferdam construction is to be done? Okay, so what are those factors which would affect the design of that particular cofferdam? So major factors which would govern the design of the cofferdam is the hydrostatic head of water. That's nothing but the depth of the water flow which is existing there. Okay, so that is going to be a major criteria based on which your design of the cofferdam would be depending on. And it also depends on the area in which that particular cofferdam construction has to be done. The dimensions of that particular area in which the cofferdam construction has to be done. And the subsoil condition, the soil in which this or the ground on which this particular cofferdam is being constructed. Okay, how is the condition of the soil there? Whether the soil is soft, whether the soil is strong. If the soil is strong, then the construction of the cofferdam is going to be relatively easy. Just by driving the sheet piles to smaller depths also, you get more stability to that particular cofferdam construction. If the soil is soft, then you have to drive your sheet piles relatively to larger depths to minimize the effect of your overturning, because the soil below is not offering you more resistance against the effect of your overturning in such kind of cofferdam structures. And we have to understand how the fluctuations of water levels are there on the outside of your cofferdam which is to be constructed. On the outer surface, after the construction of cofferdam, on the outer surface, how the fluctuation in water levels are existing. Do you have floods coming into picture? Over what period that cofferdam construction is going to be there remaining in that particular area? Okay, so do you have any effect of floods which are expected? If floods are expected, what is the depth to which the maximum level of water will be flowing there, and with what velocity it is going to be flowing there? Do you have any possibility of erosion happening in the soil layer which is there below below the water flowing region? Whether the soil is so soft where because of which due to the velocity with which the water is going to be flowing through that region, do you come across with the effect of your erosion of the soil there? So all these aspects are going to be taken into consideration in the design of your cofferdam. And do you have any floating logs like wooden pieces or anything else that is going to be floating through the surface of the water in that particular region where you are going to be taking up the construction of your cofferdam? Or do you have any presence of ice which is in static in nature, or the ice which is floating? Okay, like your ice glaciers in the areas near to your Himalayan regions. Whenever the ice starts getting melted, you see what is called as your glaciers, which are going to be running along your river cross section, resulting in heavy floods suddenly, which is going to be coming, which will be generally encountering in the areas of your Himalayan regions. Okay, so in such particular places, so do you have any presence of this ice in static condition or in flowing condition? That would also dictate like how the design of the cofferdam has to be done. If ice is in static case, the forces coming into picture because of the static condition of the ice on the surface walls of your cofferdam would be something. And if it is in a moving condition, if the glaciers are moving through the cross section where your cofferdam is to be constructed, then the force transferred because of that moving ice on your surface of your cofferdam, what you are going to be constructing, is going to be high. So you have to take care of those forces what are coming onto your cofferdam walls. Depending on that, you are going to be taking up the design of that particular cofferdam construction. Okay, these are all something what we have talked about in regard to that of your cofferdam. So what we have objective wise understood is what is meant by cofferdam, what are the different types of cofferdams that are available, which type of cofferdam is suitable in which conditions, depending on the depth of water flowing, depending on the velocity with which the water is flowing, depending on the soil condition, depending on the material availability. Okay, so we said different types of cofferdams are available depending on the necessity and the requirement. And how do we minimize the leakages that are expected to happen through the cross section of the cofferdam that is typically taken up in the construction? And what are the different factors that would that will govern the design of your cofferdam construction? So these are all what we are going to be covering under this particular concept of cofferdam in this particular course. However, in some advanced courses where you would also come across with the design of these cofferdams, like whatever the different types of cofferdams that we have talked about. So design aspect wise also, you'll be coming across with, depending on the various factors, as like what we have mentioned, taking into consideration of the water flowing, taking into consideration of the depth of the water flow, taking into consideration of the effect of glaciers existing in that region where you are taking up the construction of your cofferdam, taking into consideration of the erosion effect, taking into consideration of your subsoil condition. So by taking into consideration of various aspects, we look at the design of that particular cofferdam construction. So with this, we'll stop our discussion for today, and in our next lecture, we'll start discussing about what is meant by underpinning. Thank you.